Throughout the course of human history, technology has continued to advance in unbelievable ways, especially when it comes to autonomous cars. But that technology has to start somewhere. And today, we're going to be talking just a little bit about where that technology begins. We are Section 4, Team 3, and we were working on a line-following autonomous robot that can achieve a number of other parameters that we will be covering later in this video. Autonomous vehicles are the future of innovation and autonomy in our society. Equipped with sensors and cameras, the vehicle can detect obstacles and navigate through complex fields with ease. Controlled by powerful computer systems, these small autonomous vehicles make split-second decisions and are able to move with precision. They can be used for a variety of applications, from surveillance to delivery services, and are even very customizable. Autonomous vehicles are not only efficient, but they are also environmentally friendly, making them an excellent choice for anyone who values sustainability. Next, our group's going to talk about the control of these autonomous vehicles. This flowchart shows the basic input-to-output process that we should have the robot complete in order to have all the objectives that we've learned throughout the labs. So, there are multiple inputs that must be implemented initially for the process to be able to execute correctly. These inputs include a map of the travel area, along with proper unit conversion and final goal location. Furthermore, more complicated actions that take place can be seen in the flowchart before the system reaches a subsystem of path planning. This chooses the shortest possible path the robot can take in order to reach the designated location. Again, this is made up of several smaller complicated actions that are not shown in this flowchart but are taken. All of these inputs and commands lead to the final decision of what direction to go, if a sign is present, what action to take in its presence, etc. The robot's coding allows it to continuously run through this loop, updating itself based on what it sees as it continues its path while operating. This allows the robot to sort of think for itself, as it can make decisions repeatedly, even with changing parameters around it. The robot is able to do this thanks to several coding techniques that we have learned in the last couple of weeks of lab, the details of which we will be covering next.
In the lab 1, we designed the code to control the kinematic of the autonomous vehicles. For example, moving forward for a certain time and turning with a certain angle to arrive at a specific destination. Since the left and right motor powers of the robot are different, we need to set the motors to the speed for each to make the robot go straight. In the video, we designed the robot to go forward for a certain period, then turn right, then go forward again to stop. From the lab 2, we managed to make the vehicle follow the yellow line by itself. By utilizing and modifying the code, the vehicle would be able to follow the path and keep itself moving straight without going off track. Then we had the robot run using deep learning. We trained the robot by taking 30 shots each of the normal road, stop sign, and speed sign, which resulted in the robot recognizing each sign with its camera. Our last lab was robot networking and path planning. For robot networking, it is having communication between JetBot and CameraBot. Then we did camera calibration to make the JetBot figure out the road. By using April tag, we can figure out the X and Y coordination and the heading angle of our JetBot. Finally, we made and modified the code to find the path planning between 2 points, which is the shortest path.
There are 6 objectives in this project: basic robot control and kinematics, sign recognition using deep learning technique, path following using image process technique, robot networking and communication, path following using MATLAB, and camera calibration and position detection using AirProtect. Our team decided to achieve 3 objectives out of 6, which are basic robot control and kinematics, sign recognition using deep learning technique, and path following using image process technique. We implemented the code techniques we learned from the labs and tried to combine as many kinematic controls as possible in one Python script. Therefore, our team decided to make the vehicle go forward and make a right turn at the beginning. Then it performs path following. When the robot recognizes the stop sign, it will stop for 2 seconds and then keep performing path following.
So, that concludes our video project for the UAV labs in 435. It was very interesting just to see a little bit about how this technology works and how much we can customize it. I hope you enjoyed the video.